All right, class, welcome to another brief virtual lesson on a topic in trigonometry. So today's learning goal is to develop the sine law using acute triangles, and we'll be successful when we can identify which cases are appropriate for the sine law. All right, so before we get into the sine law, let's have a quick review of what we covered last class. We looked at these trigonometric ratios. We had this right angle triangle, right? We had a specific case where we had a right angle triangle and we were able to derive these relationships or these ratios here. Now, of course, we're not always going to have a right angle triangle, right? There's other types of triangles, for instance, this acute triangle here. So, but the idea is the same. If we have limited information about this triangle, maybe we have two side lengths and an angle, or two angles and a side length, is it possible for us to get the rest of the information about this triangle? That's the question, right? And yes, it is possible using the sine law. Now, instead of giving you the sine law directly, we're going to go through a quick derivation. So to do the derivation, we can split this acute triangle into two right angle triangles like so. So you can see we have a right angle over here and we have a right angle over here. And we know if you look at angle A and we take the sine of angle A, well, that's equal to opposite over hypotenuse. What's the opposite side length to angle A? Well, that's this over here. We can call that h. H over hypotenuse, which is b. And let's look at angle B. We take the sine of angle B. Well, that's going to be opposite over hypotenuse as well. So h over a in this case, right? Now, the h that we labeled here isn't really of importance to us because ultimately we care about the side lengths of this triangle, which is A, B, and C, and we care about the angles, capital A, capital B, capital C. So h isn't really of concern to us. In fact, I can isolate for h over here. H is equal to b times sine of A, cross multiplying there. And over here, h is equal to a sine of b. Okay, so we got two equations for b. Well, what do you notice? We got two equations for b. The transitive property tells us that we could therefore equate these two sides of the equations, right? So b sine of A equals a sine of B. Okay, now that's pretty close to our sine law. In fact, you could use this and solve for the unknowns if you're given certain side lengths or angles, you can get the unknown. However, you typically see this rearranged in textbooks. So by simple manipulations, if you divide sine A and sine B, you can end up with this. So A over sine A. And this is an exercise I'd like you to practice. But this is what you'll end up with if you just move some stuff around. And that's actually what you see in textbooks for the sine law. Now you also have angle C and side length C. You're probably wondering, well, what happened to those two? And that's another task I'd like you to try out before the start of the next class. I'd like you to figure out if there's another way you can split this acute triangle so that you get two other right angle triangles, and perhaps you can then create a relationship using sine of C. So that's one challenge I have for you. And I also want you to look at this situation here. So now that we know the sine law itself may have some limitations. It's not a perfect equation that gets you everything, in every situation. For instance, here I have 45 degrees and I have a side length here, 7. And the question is if we can solve for x using the sine law. Something I want you to look at. And then another situation is this one here. Here I have a side length 10, and I have the angle opposite that side length, which is 110 degrees. And I have the second side length, and then I'm asking you to solve for this theta here. Okay, we use the sine law in this case to solve for theta. All right, I'd like you to go through those two tasks and prepare for next class, where we'll discuss this with more practice and more in-depth examination. Thank you very much for listening, everyone. See you in next class.